For number 10, the first thing I notice about it is that it's only got two terms, which means we're starting with GCF and we're thinking maybe it's a difference of perfect squares. Well, I can get a 2x out of both of those pieces. When I pull a 2 out here, I get 8, and I take one of the x's away, I get x. When I pull a 2 out here, I get minus 5, and it had only one x, and we took it away. And now I have to reevaluate. This is the hardest part for a lot of people about factoring, is knowing when you're done and when you're not done, and what all your options are. When I'm here at 8x minus 5, I can tell I can't do anything else to that. It's not a trinomial, so I can't box method it. It's not perfect squares, two perfect squares, so I can't box method it. Okay, there's no other greatest common factor I can pull out. So really, that's as far as you can go with that problem. Number 11 is a different story. We start out the same way though. I'm going to pull a 2 out of both, and these are different variables, so I can't pull out any variables. I get 4x squared minus y squared. And then I reassess the problem. 4x squared is a perfect square, 2x and 2x. Y is a perfect square, or y squared is a perfect square. It's y and y. So we can jump straight from this to our answer because this is a difference problem, meaning I get 2x plus y and 2x minus y with my 2 out front. One piece goes here, one piece goes there, one piece goes here, one piece goes there. A lot of you don't like that shortcut because that's really tricky and a lot of memorization. If you don't, know that your box method could still work. Let's pretend we're all the way back up here at the original problem. If I was to do my box method, when I multiply my outside pieces, I'm looking for factors of 4x squared y squared that add together to be 0. I would not advise the box method on this problem. I would learn the shortcut. But I know that I can use 2xy and negative 2xy. I actually wanted that to be negative. That was my fault. I messed that up. Because 4x squared and times negative y squared is negative 4x squared y squared. So here's my pieces, and I could throw them all in the box using the ones from the original equation with them. Okay? I have 4x squared. I have negative y squared. Got 2xy and negative 2xy. Greatest common factor here gives me a 2x. Greatest common factor here is just the variable y. Another 2x, and this time a negative y. So notice we're right back to our same original pieces. 2x plus y and 2x minus y. I would advise the shortcut. Box method is real tricky with that. Number 12 and 13 start something a little bit new, but you know how to do it. And it's great because this is great EOC practice. The EOC loves asking you these problems because this is how they can ask you to factor something with a multiple choice test. Because otherwise, factoring is very, very checkable with multiple choice options. But this is one of the ways they can get around that a little bit. Okay? Which of the following is a factor of x squared minus 5x minus 6? What it's really asking you to do is, hey, factor this. So when I multiply these two outside pieces, I'm looking for factors of negative x squared that add together to be the middle term, 5x. Okay? So I think about the number 6 and what goes into it, 1 and 6, 2 and 3, and actually both of those seem like they might work. So I start with the first one. I try 1x and 6x and I see if I can get it to work. Well, if I need these to add to be negative 5x, I've got to have a negative sign there. When I add them, I get negative 5x. When I multiply them, I get negative 6x squared. So that worked. For anyone that did it with 2 and 3 and said, well, I did it with 2 and 3 and got the right answer, let's look at this. So just ignore what I'm about to work on if you are okay with what I just did. And let's see. If you said, no, I used 2 and 3. Let me show you why it doesn't work. The only way to add these and get negative 5x is for them to both be negative. And then when you multiply, you're going to get a positive 6x squared. So no, negative or 2 and 3 cannot work. It has to be 1 and 6. Factoring things is very unique. Okay, there's only one right way to work these with the factors. But again, we're back to our original way we were working this, and we're ready for the box. X squared, -6, and then our creative way of breaking up -5x goes in these diagonals. 1x, -6x, and now we're ready to greatest common factor. Here we get an x. If you can't pull anything out, you at least can pull out a 1. Please don't forget. Here we can pull out an x. These have the same number in front, so we can take a 6 out of both, and because this is negative, this is negative. Again, because there's a leading 1 out front, you could actually have gotten this answer right from this step, because you'll notice we get our answer as x plus 1, which is the same as one of our pieces, and x minus 6, which is the same thing as one of our other pieces. But that only works with a leading coefficient of 1. So just be careful. Make sure you understand when you can use that rule and when you can't. Okay? So our final answer, which of the following is a factor? C. Notice they put a minus sign there. They're trying to get you. Number 13 is the same question, but more difficult. So I want to find a GCF of all of these, but I'm not going to be able to do it. Because if I think of my 7s times table, 7 times 7 is 49, but 7 times 8 is 56, which means we skip right plain over 52. Meaning we've got to just hop right into this with the box method. 7 times 21, well, I think that's going to be 147. But judging from my last problem that I tried to do that on, I know I'm going to hop over in my calculator and check it. Plus, I don't want to have to find all the factors of 52 by myself. I want to let my calculator help with that too. Okay? So what we were doing was 7 times 21. It was 147. We want factors of 147 that add to be 52. I think I may have said the wrong number a second ago. So 147 divided by x, and we look at the table. I'm thinking 52 in my brain. 52, 52, 52. Okay? So I'm adding and subtracting these numbers in my head, hoping to get to 52. And the one that sticks out is one of the only ones that worked, 3 and 49. So I'm going to try 3 and 49 first. Okay? 3b, 49b. If I add them, I get 52b. If I multiply them, I get 147b squared. So those are my pieces that I need, and I'm ready to throw them in the box. Along with 7b squared and 21. So we've got 3b. Doesn't matter where you put them, as long as you put them in there. 3b, 49b. Greatest common factor here, just the variable b. Just the variable b. Greatest common factor here, you got to know your times tables a little bit. 7 will go into both of those. Okay? Greatest common factor here is a 7 again, but this time with a b. And my greatest common factor here is 3. Okay? My answer would be b plus 7 and 7b plus 3. And the only one of those that shows up is, ooh, careful. I almost circled this. I saw the 3 and the 7 and the b in there. I was like, ooh, there it is. Nope. 7b plus 3.